everyone, I'm Araks. I'm a senior iOS engineer and I worked in a bunch of companies when working as an iOS engineer. And I wanted today to share some approaches that can help you write cleaner, more predictable, and easier to maintain code. I think we all felt that our iOS app state management is a tangled mess and struggling to keep track of changing data and ensure that our UI updates are always in sync. I think we've all been there, and managing an app state can quickly become a complex web of code, making it difficult to reason about and maintain. And one approach we'll explore today is functional programming. Functional programming focuses on building programs from pure functions and immutable data. This focus on immutability makes your code more predictable and easier to test. We'll also delve into reactive programming, a paradigm for handling data streams and UI updates in a declarative way. Also, today's talk will demystify these concepts, functional and reactive programming, and show how they can be applied in the context of iOS app development. We'll see how frameworks like Combine can use those principles and provide more practical solution for state management. And finally, we delve into some hands-on examples, and we'll compare traditional state management approaches with the functional reactive approaches we've discussed. So let's delve into the core principles of functional programming that makes it a powerful tool for state management in our apps. Functional programming is a programming paradigm that treats computation as the evaluation of mathematical functions and avoids changing state and mutable data. This approach emphasizes the use of pure functions, immutability, and higher order functions to create more predictable and reliable code. One of the core concepts introduced is immutability. Imagine building a house of cards. When looking to it through the lens of functional programming, add a new card creates a new structure, not modifying the existing one. This concept of immutability is a core principle in functional programming. In state management, it means we don't directly modify the data, instead we create a new state object with the desired changes. This eliminates the risk of accidentally mutating data and causing unexpected behavior. So our data is immutable. We need new state objects for updates. Here's a simple example. In the traditional approach, we directly modify the tasks array, and in the functional approach, the addTask function creates a new array with the updated data and leaving the original tasks array untouched. Another key concept is pure functions. These functions always produce the same output for a given input without any side effects. They don't modify global state or interact with external resources. This makes them predictable and easier to test. Here, the traditional update task function modifies the global tasks array, making it impure function, as we call it. And the functional approach creates a new copy of the array with the update, ensuring consistency and avoiding side effects. Another key concept is first-class and higher-order functions. Functions in functional programming are first-class citizens, meaning they can be assigned to variables, passed as arguments, and returned from other functions. Higher-order functions are functions that take other functions as arguments or return them as results. This allows for greater abstraction and code reuse. By using immutability and pure function, functional programming offers several advantages for state management. With immutable state, you are less likely to introduce bugs by accidentally modifying data. Pure functions make reasoning about code easier, as the output is always consistent for given input. Additionally, functional code tends to be more modular and easier to test in isolation. While the functional programming has its benefits, it's important to acknowledge some potential drawbacks. Learning functional programming might require some initial investment, especially for developers without prior experience, and additionally, expressing complex logic with pure functions can sometimes lead to more lines of code compared to imperative approaches. However, the benefits in terms of code maintainability and predictability often outweigh these drawbacks. But I know at this point all the above might sound like mostly theoretical concepts, but functional programming has the potential to give us some very real practical benefits, from increased reuse and testability to more predictable code. And it's actually being applied in Swift language. In Swift, for example, immutability is being achieved using our well-known let to declare constants. Once value is assigned to a constant, it cannot be changed. In Swift, also functions are first-class citizens, meaning they can be assigned to variables, passed as arguments, and returned from other functions. And higher-order functions are the functions that take other functions as arguments or return functions as their results. And Swift standard library includes many higher-order functions, such as map, filter, and reduce. So we can see how much is being applied and used in Swift. Next, let's explore reactive programming. It's a very powerful paradigm for managing data streams and keeping your UI in sync with changes in your iOS apps. Imagine data flowing through your app like a river, and reactive programming treats this data as streams of events, allowing you to react to changes in a declarative and efficient way. UI elements become like a ripples on the surface of the river, automatically responding to the flowing data. Reactive programming has several key principles that make it well suited for state management in iOS apps. Instead of writing step-by-step instructions on how to update the UI, you describe how the UI should respond to changes in the data. This makes the code concise and easier to reason about. Secondly, it's data as a streams. Imagine a stream of network data arriving in chunks and user interaction events happening one at a time. Reactive programming allows you to process these events efficiently as they occur. I like traditional approaches that rely on polling for updates. Reactive programming is event-driven. Your app reacts to specific events, changes in data streams, triggered by user interactions or other events. This leads to more responsive and efficient user experience. For instance, user taps a button, which is an event, and which triggers a network request, another event. The response from network request becomes an event that updates the UI through the data stream. This eliminates the need for constant polling and makes the app more responsive to user interactions. By using these core principles, reactive programming offers several advantages for state management. Declarative approach simplifies UI updates, while treating data as a streams allow us for efficient transformations and filtering. Additionally, the event-driven nature promotes a more responsive app that reacts to user actions and data changes immediately. While reactive programming has its merits, there are some potential changes to consider. Understanding core concepts like publishers, subscribers, and operators might require some initial investment in learning. And additionally, debugging issues with complex data streams can be more challenging compared to more traditional approaches. Visualizing and tracing the flow of events might require some additional effort. In my experience with reactive programming, when I started with Objective-C, it was reactive Cocoa framework that I used. Later, I moved to Araks Swift when I started to writing in Swift. Then Combine was introduced in 2019. Then in Spotify, we were using Mobius, which is a functional reactive framework. Then we had Observation Framework released in 2023. So we had a lot of things happening in the last few years. Here, I'll try to talk a bit about Combine, which is Apple's framework for reactive programming for iOS, and it empowers you to manage state in functional and declarative way. So what is Combine? It's a powerful framework built into Swift, uses the principles of reactive programming. It provides a way to define data streams which are publisher that emit values over time, and allows you to react to those changes using subscribers. Imagine a stream of events going through your app, and Combine allows you to define what events are emitted, which are publishers, and how different parts of your app react to those events, which are subscriber. This approach promotes a more declarative and reactive way to manage your app state. Combine offers several key functionalities that make it good for state management. Think of a publisher as a source of data, like a newsfeed that emits new articles. Subscribers are like readers who react to new articles being published. In our state management context, the publisher could be a state object that emits updates whenever the state changes, and the subscriber could be a UI element that updates itself based on the new state. Combine provides a rich set of operators that allow you to transform and manipulate data streams. You can use operators like map to transform values, filter to select specific events, or combine lattice to merge multiple streams. These operators enable you to build complex data flows in a modular and declarative way. Here's a simple example. We define current value subject publisher that emits integer values. We then use the map operator to transform the integer into a string for display. And finally, we use assign_to method to bind the data stream to the text property of our label. When we call send10, and the publisher emits a new value, which is a state change, and the label's text automatically updates to 10 due to the binding. Combine excels also at handling asynchronous operations and error management seamlessly within your state management logic. And imagine a network request that updates your app state upon successful completion. Combine allows you to integrate this asynchronous operation within your data stream. And additionally, Combine provides built-in error handling mechanism to gracefully handle potential errors during data processing or network requests. By using Combine, we gain several advantages in state management. The declarative nature of Combine simplifies UI updates, as UI elements automatically react to changes in the data stream. Additionally, Combine integrates asynchronous operations seamlessly within your state management logic. And furthermore, Combine provides built-in error handling and cancellation mechanisms, leading to more robust and maintainable applications. While Combine offers significant benefits, there are some potential considerations, as we all know, because there is a big uncertainty from Apple regarding its future. But let's look at some hands-on simple example. We'll build a simple counter app and compare how we manage state traditionally. In this case, we'll use MVM and with Combine. In the traditional MVM approach, we typically have a view model responsible for managing the app state and exposing observable properties for the view to bind to. We might also have separate methods for incrementing and decrementing the counter. Here we have a counter view model with an int property for the count and methods to increment and decrement. The counter view controller holds a reference to the view model and binds the counter's label text to the count property. Button taps trigger the view model's methods, update the count, and then we are manually updating the label's text in the view controller. With Combine, we can manage the state in a more declarative way. We can define a publisher that emits the current count and use operators to react to changes. The view can directly subscribe to this data stream and update itself automatically. Here, the view model uses the published property writer to create a publisher that emits the current count whenever it changes. And button tap still triggers the increment and decrement methods, but the view controller now subscribes to count property stream using assign_to method. This automatically updates to the label text whenever a new value is emitted by the publisher. This example highlights the benefits of using Combine for state management in similar application. The declarative UI updates. The view directly subscribes to the data and updates automatically, eliminating the need for manual updates in the view controller. And it's improved readability for some. The code becomes more concise and easier to reason about as the data flow is more explicit. Let's see the use of the Combine with the network request. Let's see how Combine tackles the more complex scenario and managing user profile with a network request to fetch user data. We'll compare the same traditional MVVM approach and Combine approach. In traditional way, we might have separate view models for the user profile and the network service responsible for fetching the data. The user profile view model holds properties for user information and the method to fetch the data from the network service. The view would bind to these properties and potentially trigger the data fetch action. Here, the user view model has properties for user data and a reference to the network service for fetching the data. The fetch user profile method triggers the network request using a completion handler. The completion handler updates the view model properties, but manually notifying the view about these changes might be required, using delegates or closures. With Combine, we can model user profile data as a publisher and use operators to handle the network request and update the UI declaratively. Here, the user view model uses publish property wrapper to create a publisher for the user data. We inject the network service that returns a publisher of user data or an error. And upon initialization, we subscribe to network service publisher, and the subscription closure handles the following. Firstly, it handles data transformation. The closure uses the map operator to transform incoming user data, which is a response from a network to a user object. This might involve extracting the relevant data, like let's say first name and last name from the network response. Secondly, it's error handling. The closure also handles potential errors using the sync operator. The sync operator here provides completion and value callbacks, and we can use the completion handler to check for errors and potentially display on alert or handle error gracefully in the view model. And thirdly, it's assigning the updated value. Once the data is transformed, the closure assigns the new user object to the user property. Important to note that we also utilize like store-in cancellables to manage the subscriptions lifecycle and prevent member leaks. This is essential when dealing with subscriptions in Combine. By using these operations and the publish property writer, Combine enables a more declarative and reactive approach to data flow and UI updates in our view model. But let's look in comparison between Combine and async await, since when talking a lot about Combine, we are getting this question, how they are being compared and what to use when. Combine and async await are both powerful tools for handling asynchronous operation in Swift, but they serve different purposes. There are two different tools for two different problems. Those two problems are closely related though, so people often compare them. Async await is a tool to help with general concurrent programming. Combine, on the other hand, is a tool to help with event-driven programming. Event-driven programming can be seen as a form of concurrent programming, which is why people often say you can use Combine for asynchronous things, and why many people, as well as I used it before, like Swift 505, introducing of async await. Combine is a reactive programming framework that excels in managing complex data flows and creating reactive UIs. It offers a declarative styles, allowing you to define data pipelines using operators. Async await, on the other hand, is a language-level feature that simplifies writing asynchronous code by making it look and feel like synchronous code. It's particularly useful for straightforward asynchronous tasks. The choice between Combine and async await often depends on the complexity of your asynchronous operation. For simple tasks, async await offers a more concise and readable solutions. However, the intricate data transformation and managing multiple asynchronous events combines declarative approach might be more suitable. I think main difference between, let's say, functional reactive programming, in this case Combine, and async await is event streams of multiple values versus one value. Let's look at the more practical example. In the Combine block, the code is slightly less complex, and the addition of map and decode and map error help make it more readable. In this async await code block, not only is there less code, it's easier to understand what the code does in a way. It sets the path, it creates the path request, it makes the call, and it sends the data back. The comparison of these two approaches really becomes clear when you look at synchronizing calls inside of the same function. As you can see, we have the method here called load restaurants, which load query by restaurants and then by categories. Result of the first call, getting a list of restaurants by name, must come back to complete the second call, getting a list of restaurants that have the same category as the initial result. Managing the response from the initial call is rather difficult, especially if we need to update sensible information. about an error when something does go wrong. That difficulty only increases when we become reliant not only on a successful response, but also rely on the data as a result of that second response to power the second request. And this is how it looks when we can use a single await. So the changes of the function method length is pretty obvious. For example, this kind of cases, a single await is more suitable personally for me to use. Another interesting comparison can be between combine and observation. Combine is not only event-driven programming framework for Swift. Swift observation was introduced as part of WWDC 23, which is an environment-independent framework. The only issue for some is that it runs only on iOS 17+, and not all engineers and engineers will be able to use that because not all apps are ready to use only iOS 17+. So for comparing combine with observation, let's kick things off with an example of how we've been building Swift UI applications so far. Let's create a simple app containing just a text element and a button. We'll throw in a counter with an initial value of 0 that increases with each button click and print out the value inside of our text element. To make it slightly more demanding, let's use MVVM as our architectural pattern, and this means we should put the counter logic inside the view model, keeping the business logic outside of it. By using combine framework inside our view model, we can mark the variables as published, allowing view models to communicate to changes back to our views, and make them re-render their user interfaces whenever change occurs. We also need to make the whole class conform to the observable object protocol, which synthesizes an object with change publisher that emits the change value before any of its published properties change. Of course, Swift UI uses the principle of mutual communication, so we need to mark the initialized view model variable as a state object inside our view. And without this property wrapper, Swift UI will not update the view whenever a new value is stored inside the count variable. Another reason is that Swift UI views are structs, and we all know we cannot store mutable properties inside structs. Finally, by building and running our code, we can see everything works as expected. Upon button press, the text element is being updated, and we can see an increased value on our screen each time. When looking at observation framework, we can see in the end that to declare type as observable, we need to attach observable macro to the type declaration. So let's do it, and adding observable macro to our view model, and we are removing every part of the code that has anything to do with combine. This includes the publish property wrapper, as well as conforming to the observable object protocol. Removing the protocol conformance, we cannot have state object in our view anymore. So we'll just make it a simpler state. Let's see it's in action. And with just 2 lines of code inside our view model, one importing the observation framework and the other one just adding observable macro, we can get rid of combine completely, and our app will work just as expected. Nice things about macros that they add code for us and can be expanded by right-clicking and choosing the expand macro option in Xcode. And let's do exactly that and see what the macro added for us. So going from the bottom up, we can see that it adds conformance to the observable protocol, the observation register used inside methods access, and with mutation, one, and the observation tracked variable, and one observation ignore variable. The most important things to notice are observation register variable and the 2 methods, access and with mutation. What the register actually does is whenever someone either looks or changes the observation tracked properties, it gets notified. It can therefore communicate these changes directly to the Swift UIs that are watching. By inspecting this access method, we can see that each time someone tries to access one of the properties, the attempt gets stored inside the register. The same thing happens if someone tries to mutate one of the properties. The mutation is registered inside the very same register using the with mutation method. Combined topic can be very controversial. I feel it's or you love it or hate it, and there is no in between. If you have new app and just writing from scratch, you might as well not use Combine at all. If you are working on older and bigger app, chances are high that you have Combine in your code, and that is completely fine to continue to use it, because personally I think it's gonna stay there. There is no new methods being added to Combine from Apple, because I feel it was released as already complete framework. But saying that, if talking about Combine, I think it's we need to mention about async algorithms. And if you prefer how to migrate, and we can see how we can migrate to async algorithms from Combine. We'll have complete cycle of Combine depending where are you in the stage of your development of the app. There are 2 blog posts I found about some small changes you can do on migration to Swift async algorithm. One of them is from Paul, and it's about async streams, and another one from Jacob Bartlett, and more in-depth migration example. I'll try to share what I've done and a few examples from it. So, what is async algorithm? Async algorithms package was published in 2022. Much of functionality in Combine is now also available in Swift concurrency. For understanding async algorithms, there is one protocol we need to take a look at, which is async sequence. Async sequence works a lot like regular sequence protocol in the Swift standard library. It provides an asynchronous version of the iterator protocol that offers async iterated access to the next element. The iteration can be evoked using for await in syntax sugar. Async sequence should be very familiar if you are coming from Combine publishers. Both deal with streams of values over time. Many of the algorithms in async algorithms package therefore serve as drop-in replacement for corresponding Combine operations. Let's see, we have a view model and we have a method for subscribing to articles that we are fetching from the repository. In the view model, this is the Combine example. We originally used the Combine latest because we wanted to merge 2 streams together. Let's say we are fetching articles from 2 places. We have like first article subject and second article subject. This is combines like bread and butter, publishing values from multiple data sources and combining them together. This modifier publishes pairs of values each time either publisher sends anything. For our articles list, this means we can always be sure it's combining the total number of new articles from each source, such as different news websites. This ensures our users see the correct list of articles. The most critical thing to understand when moving from Combine to async algorithm is the way we iterate through values. Instead of handling streams of values with sync operator, we are now iterating through an async sequence using for awaiting syntax. We combine the streams from the repo using the Combine latest algorithm, which has virtually identical syntax to the Combine form. Since we are assigning property on our observable view model, we put this method on the main actor to ensure thread safety. The single main actor attribute neatly replaces the receive on run loop main, which we used here. And the for awaiting syntax serves as a suspension point between each iteration of the stream. The waiting itself is happening off the main thread. Another key change in migration will be if you are using Combine that you are definitely using current value subject. And when migrating, we will need to move it to async channels class. Async channel is type heavily inspired by Combine subjects. It's a special type of async sequence which applies back pressure. This means it's buffer values. It waits for a value to be consumed downstream before calling the next function on its iterator. Let's have a look at this example. We are fetching the data from the network service and sending the articles data or an error to a current value subject. This caches the latest value, making it easier to share the data across your app without performing lots of additional networking. First, when migrating from Combine to async algorithm, we modify article subject to article channel. And it moves from current value subject to async throwing channel. Since these concepts we have the same, we hardly need to modify load user at all to get the repo to its final async algorithm form. The only difference is swapping out the unhappy path code branch from send completion failure that we used here to the much more intuitive fail error. Let's recap some key takeaways from functional and reactive programming and their application to the state management in iOS apps. We explored how functional programming principles like immutability and pure functions can lead to more predictable and maintainable code. We also saw how reactive programming allows you to manage data streams and UI updates in a declarative and maintainable way, and simplifying our apps react to changes. And we take a look at the Combine as a framework that uses this concept and provides a toolkit for state management in iOS development. We also looked in comparison with async await, observation, as well as migration to the async algorithm. So we kind of did a full cycle of introducing Combine and migrating to it. Important for me is that to explore other frameworks for reactive and functional programming, and because it's not only Combine out there, understand that you need to think twice before adding any third-party library, and you should be cautious. But there are also very nice reactive programming third-party libraries that you can use. Explore those other libraries to find the best fit for your project. There are many resources available online to help your deepen understanding. It's important to balance efficiency with simplicity. While frameworks like Combine can streamline development or any other reactive programming frameworks, we need to avoid over-engineering. There are cases when simpler solutions are more suitable. Don't feel the pressure also to use the latest API or framework. There are many things being released in Swift and many changes. I know it can feel very overwhelming to keep up with all the new stuff, so we can just make small steps and see what works for us. And most importantly, enjoy the process. Engineering should be fun. If it's not, pivot, explore alternative code strategies. And that's all from me. Thank you.
Thank you very much, Araks. We will do some questions. Yeah, anyone have any questions? Please don't start walking out now. Please just sit down and wait. We're done in 2 minutes, right? Just wait. Please just sit down and wait. Thanks. Any questions? Nope. That's good. See, we were done super fast. There is lunch now. And there will be a quiz by Nikolai and the crew at the JetBrains thing. There's a question. 2 seconds. So go there at 2 in the lunch break. There's a quiz, I guess, also, I would assume prizes or something. Yeah. We have one question down here. Yes?
I have the same question from yesterday. So about Combine and the concurrency, do you have some hints for us? Or just keep with Swift 5 and let's go?
It depends, as Nick said. So personally, in my side project, I was moving from Combine to Swift async algorithms because I could update to the latest iOS versions. But in the companies that I worked, and especially if it's big tech companies, there wasn't upcoming change to move from Combine, so I was still using Combine and not migrating to anything new. So it depends what you can do in your company, what are the priorities. If you can prioritize that, I think you can move to async algorithms, but if it's not high in your priority list, I think you can continue using it.
But you think that Apple will update Combine in the future to make it feasible for Swift 6 or not?
To be honest, I don't think so.
Very well.
Good.
I would like to, but...
Well, thank you all very much for this session. And one more time, thank you, Araks.
Thank you.